Graphing polar coordinate equations. Our job is to be able to graph a polar equation of this form. So r is equal to 2 cosine theta plus 1. Now I'm going to do this for the angles here on the unit circle I've written out to make this quick. So we're going to figure it out for angle 0, pi over 4, pi over 2, and then so on. So first let's graph our first angle. So what about r of, say, 0? Well, this is 2 cosine of 0 plus 1. And what we know is the cosine of 0 is going to be the x-coordinate over here. So this is 2 times 1 plus 1. So 2 times 1 plus 1, which we get 3. And I'll start labeling the points over here. And now these points are going to be in polar form. So this would be in polar form. So our first point is going to be angle 0. R, or distance from the origin, is going to be 3. So then we'll try pi over 4. So r of pi over 4. So this is 2 cosine pi over 4 plus 1. We know that the cosine of pi over 4 is going to be the x-coordinate. So this is 2 root 2 over 2 plus 1. So this is root 2 plus 1. Root 2 is about 1.41. So this is going to be about, so let's go about 2.41. Or if you want to just write root 2 plus 1. But I'm going to graph this thing and I want to kind of know its exact value. Well, not exact value, but its approximate value to graph it. So r of pi over 2, 2 cosine of pi over 2 plus 1. Cosine of pi over 2 is the x-coordinate, so this is going to be 2 times 0 plus 1. So this is going to be equal to 1. So we're filling out points here. So the next angle is going to be pi over 4, and then we have 2.41, and then we're going to have pi over 2, and this is going to be 1, and then so on. So we can continue this with, all these angles. So r of 3 pi over 4, and we're kind of getting the hang of this. So this is going to give us negative 0.41. R of pi is going to give us negative 1. R of 5 pi over 4 is going to give us negative 0.41. R of 3 pi over 2 is going to be equal to 1. R of 7 pi over 4 is going to give us 2.41. And R of 2 pi, we like to do the full revolution, is going to be equal to 2 cosine 2 pi, so 2 times 1 plus 1, which is going to be 3. So filling out our points here, so we have 3 pi over 4, negative 0.41. We have pi, comma, negative 1. 5 pi over 4, comma, negative 0.41. 3 pi over 2, comma, 1. 7 pi over 4, comma, 2.41, and then finally we have 2 pi, comma, 3. So when we graph this, and we'll do this over here, remember these were able to find the angles for the cosine function, and eventually we'll do one for a sine function. But when we graph this thing, I'm going to graph this on its own coordinate system again, and we have to do this for the angles. I'll do dotted lines just to make it kind of nice for us, so we can see those 45-degree angles, or those pi over 4s. And I know that the largest distance from the origin is going to be 3, so I'm going to do 1, 2, 3, 1, 2, 3, 1, 2, 3, and then so on. So now when we plot these points, for the very first one, we know that we're going to have 0, comma 3. So angle 0 is here, and then it's going to be at 3. So it's going to be this point right here. And next we're going to have angle pi over 4, which is going to be this angle here, and I got 2.41. So this would be distance, 1, distance 2, distance 3. So 2.41 is going to be about right there. Now, then I have at pi over 2, we have 1, which is going to be here. At 3 pi over 4, which we know is this angle, instead of going 1 in this direction, going in its angle direction, what this is it gives us negative 0.41. So what we're going to do is we're going to go this way. So at this angle we're going negative, so it's going to be about right here. pi, which is this angle, but it's going to go to -1, so it's going to flip over the other side, and then 0.41, and then this is going to be at 3 pi over 2 is going to be 1, so back to positive, so 3 pi over 2 positive 1, so it's going to go in the angle's direction. And then 7 pi over 4 is 2.41, so 1, 2, 3, so 2.41 is going to be here. Now, I'm plotting this, it went from here to here, and then to here, and then here, and then so on. So that's what we get. Now, this thing, they have a name for it, and it's called a limicon. Probably brutalize that, but that's what it looks like. So we're going to do another one that's a cardioid, and then we'll see why they actually call it that. So our new formula is going to be, we'll do exactly the same angles here, except our points are going to be different. So erasing this will generate a new curve in polar form. So now we have one minus sine theta. So let's use a different trig function and some subtraction to give us some variation. Okay, so for the exact same angles here, we're going to find, points again. So this time we're using the sine function. So, our quick look, we're going to be using the y coordinate for sine. So this one is going to be 1 minus, the sine of 0. Now the sine of 0, this angle is going to give us the y coordinate of 0. So this is 1 minus 0, so this will be 1. Now pi over 4, the sine of pi over 4 is the y coordinate, so this is root 2 over 2. So 1 minus the sine of pi over 4, which is 1 minus root 2 over 2. And that gets us about 0.29. As an approximate. Remember, we're trying to graph this, so it's kind of nice to know what the value it approximately is. And then r of pi over 2, so this is going to be 1 minus the sine of pi over 2. Now, pi over 2 is here, so this is going to be 1 minus 1, which is going to be equal to 0. And then we can kind of just go through the rest of that. 3 pi over 4, we're going to get 0.29 at pi. This is going to be 1 minus what the sine of pi is 0, so 1 minus 0 is going to be 1. At 5 pi over 4, this is going to be 1 minus a minus root 2 over 2, so this is going to give us about 1.71. 3 pi over 2, which is going to be -1, so 1 minus a -1 is going to be 2. And then 1.71, and then back to 1. So our points in polar form are going to look like this. So we have, angle 0, distance along that angle is going to be 1. Then we have pi over 4, 0.29, pi over 2, 0, 3 pi over 4, comma 0.29, pi, comma 1, 5 pi over 4, comma 1.71, 3 pi over 2, 2, 7 pi over 4, 1.71, and then finally our 2 pi right back to 1. Okay, so when we graph this, let's use the same blue marker, it's so vibrant. So when we graph this, we know that our furthest distance away is going to be 2, so I'm going to make our radii 2, and then I'll put some 45s in there, or pi over 4s and so on. Okay, so the first one is going to be on angle 0, but it's got a radius of 1, so it's going to be right here. So angle 0, radius of 1. Next is going to be pi over 4, 0.29. So this would be 1 unit away, so 0.29 is going to be about right there. Then I'm going to have pi over 2 comma 0, which is going to be right here. And then 3 pi over 4, which is going to be 1. So we don't have any negatives in this. So they're all, along that particular angle. So, 0, 1, pi over 4, 0.29, what's needed is pi over 2, comma 0 units away, and then so on. So this is 0.29. Pi, comma 1, so this angle pi is going to be at 1. 5 pi over 4 is going to be at 1.71, so this is 1, this is 2, so closer to 2 than it is to 1. 3 pi over 2, we're going a distance of 2 away, and then to that 1.71, and then at angle 2 pi, we get right back to 1. So we get it when we graph this as we see this. Something that looks like this. Now this is why they call it a cardioid, because it kind of looks like a heart. Which is a good spot to stop. Thank you.